Hey, what's up everybody? Ed the Pond Professor here. I am in Bloomingdale, Illinois. This is the site of a retention pond that I visited during my retention pond vlog a couple weeks ago. Now we're coming in to actually do the renovation. You can see the pond back over here behind me. We started draining the water down. Caterpillars dropped off our heavy equipment so we could start removing some of the cobblestone and some of the fencing and everything around the perimeter. So that'll allow us access into the retention basin. Trash pump connected, draining water down. And unfortunately, we have had a lot of heavy rain recently. Of course, our retention pond is doing its job. It was all the way at the overflow. So we are slowly draining the water down, and now we have really saturated soil conditions around the perimeter. Started removing some of the manufactured retaining wall blocks. Those were situated right here. We're going to take the skid steer, we're going to push some of this soil and gravel mixture down into this edge over here so we can kind of create a ramp. We're going to try to get heavy equipment in here. This is also going to allow us access for our large polypropylene liner, which weighs 5,000 pounds. So we need a lot of access. Making progress. Weather's not cooperating, but it's late in the season right now. Now you might be asking yourself, why are you worried about how much water is inside of a retention pond? So this pond originally built, the water level was not holding at the proper elevation. Last several times I've been out here, the water level was even lower than where it's currently at. So they were never able to get the pond full. Unfortunately, we had a bunch of rain and the pond was overfull. But traditionally, for the past few years, this pond has not been able to hold water. So that means it's leaking. So the contractor came in and he tried to put in bentonite clay to fix up the edges. But again, what's the reason? This is specifically designed to be at a specific elevation. Water level is supposed to be up here at the base. If it's not, when the water's down low like this, and then it gets a rain, the water level rises up. And then it slowly declines. So you constantly have this flushing action. When it does that, it starts pulling and eroding some of the soil and the material away from the side. And what happens is that material goes all the way down to the bottom. The other thing that's happening, because of the depths, starting to get lots of aquatic vegetation growing around the perimeter. This pond is actually designed during a heavy rain to not only just be here, it's actually designed to flood all the way up to the top of this. And then it slowly gets discharged through a series of these restrictor pipes. It allows a specific slow volume, like a trickling action of water, and then over several days it'll slowly drop down. So during that process, all the sediments, all the junk, all the stormwater that comes into the pond will have a chance to settle out on the bottom of the pond. Now these ponds are typically designed to have a lifespan of approximately 20 years. Once they've exceeded the lifespan, the volume starts to diminish. There's all the sediments down on the very bottom. Over the years, sediments slowly build up till you get many feet. The water volume changes, dissolved oxygen changes, the water temperature changes, and the whole system starts to crash. You start to get all types of algae blooms. So it's kind of the death of the pond. So what you need to do then is you need to come back in, suck all the material out and dispose of it, and then you're going to be ready again for another 20 years. So this is part of a filtration system. We're going to pull all of this material out, all the vegetation, all the rocks, put in our rubber lining, and then we're going to reestablish and put those stones around the perimeter. Once we do that, the water level will be at the appropriate elevation, and then this will be able to function for many, many decades to come. Continue pumping water out, but we seem to have found a problem, and I think we have a solution. All right, Jeff, what do we have?
So we have a sewer plug. We have a spot over there and a spot right here that are coming from the street. And what happens is the water just keeps filling this pond up, and we're trying to pump the water out. So any water that's coming in is going to give us a hassle. So we're going to put these plugs in, we're going to fill them up with air, and they're going to stop all that water from coming back in the pond. Hopefully we can just pump it out.
Nice. All right, so we got to pump that guy up to 25 psi. We got our compressor, and the sewer plug actually comes with a handy gauge right here. So we will pump that up and hopefully stop our problems. We got our Cat 304. We also have a little walk behind ditch witch because we can't get a skid steer along this edge, and within the 1 seconds we got it stuck. All of our materials, everything's coming together from a logistics standpoint. Problem, still, we have a lot of water coming in this pond. We got some river rock over here. We also got some crushed stone to create a ramp area, and that'll help give us a little traction so we can get our mini excavator down into the bottom. The large skid steer over here, that's gonna help us move bulk materials. Also, that's gonna help us to move our liner roll. The Cat 304, brand new machine, really nice. And that's gonna do all of our trenching work, as well as create a sump pit someplace over in this corner. The original contractor, he basically dug the ponds and put that material on the edge. He also came in and did some bentonite clay. Is a common material that contractors will use to seal up a leaky pond. It swells up when it gets wet, and it actually creates an impermeable barrier. So it actually is very, very effective. Problem is, it wasn't really tilled into the soil, so it's just kind of laid on top, and it's really thick, and now it just turns into like this nasty pudding. Right over here where those little rocks are at, that's one of our aqua blocks. I have our suction line coming from our trash pump, and it's going inside of the aqua block, and that's acting as basically a big pre-filter. These blue tubs, super, super handy, collapsible. We use them for pond clean outs to fill up while we're going to clean a pond, and we hold fish in them. Somebody must have released some goldfish in here, and they have been breeding, and there are a lot of goldfish right now. You can see Jeff and Nick over on the other side. You can see all that nasty stuff. So all those were laid up right in here. We're basically picking them up, shuffling from the bottom, and then we're throwing them up out of the top. Another challenge, another layer of complexity on top of everything, but I do think it's going to be a big improvement, which is the whole reason why we're doing it, trying to help with the overall watershed of the area. There is a wooded wetland back over in this section, so this is helping to protect the wooded wetland. Wooded wetlands are not very common in this area. Guarantee that's home to all types of wildlife, as well as plant species that are found in that type of a habitat. So I was just repositioning one of the pumps, and I found another source of incoming water. It's actually kind of unique though for Illinois, so it's kind of cool, I guess. That is a spring. I guarantee if there's one, there's more. I just sink, and I continue to sink. But what I want to show, you see this nasty, gray, sloppy stuff. So that's the bentonite clay that is, oh God, causing problem for us along that entire edge, which is why we're coming in with a large polypropylene liner. That's going to create a 100% waterproof barrier for us, and I know it'll do the job. All right, so we got some good news and we have some bad news today on our project. Good news is it's well below freezing right now, so the mud froze. So now we could actually walk around. Bad news, I had this pretty much drained last night when I left here in the dark. It filled up several feet. That is a problem. Here's our current plan of attack. We're figuring out ways of alleviating the long-term issue and then putting that water to our advantage. Jeff is moving the excavator into position. We're going to dig out some of the sediment over in here, and we're going to create a channel going over into the far corner so everything drains into that corner. I want to de-water not just the pond, I want to suck water from as big an area as possible. That will allow us to dry everything out. Again, with the engineers, we are having freezing temperatures. It's going to keep getting worse and worse and worse. Thankfully, they're very willing to work with us. We're helping them out as well. So they want it done, but they also want it done right. We're not willing to cut a corner just to get it done this year, and we want to make sure that's going to last for many, many years. Trench has been dug. We have a deep section coming out about 10 feet out, going down about 24 to 36 inches below water level. We're digging a hole there that's going to be at least a foot deeper, so everything goes into that section. Then we have our pipes, which are perforated. They're going to get installed. We're going to fill around it with all of that 1.5 inch river stone. So we have hundreds of 3/4 inch holes going through, providing a lot of room for water flow. We'll put that 1.5 inch rock. That will not go through those. So that's going to allow all the water to get to our pump that's going to be located at the bottom. We were digging, and I don't know if you can see this, but we're undercutting that entire wall. We got our pipes in. I would have liked them a little bit deeper, but I did not want to risk it. So it's that fine line. Continue shoveling some of this gravel in. Once this is done, then we can connect that up, and I feel a lot better. These are basically an underliner drainage system. Covered it with 1.5-inch river rock, and then we just topped it off with this 3/4 clear, just to kind of keep soil and stuff from migrating down into that 1.5-inch gravel. So now what I'm doing, the pumps that I'm using, Surumi 12PM. This is a good solid workhorse. We have been using these guys for decades, literally. Could suck up a lot of gravel. It's a very powerful pump. It'll draw material in. Under normal circumstances, I would pour a layer of concrete down on the bottom. I can't do that here. So what I did, very simple solution. I took the little rubber feet off, and then I cut this little plate. This is just some standard 12-inch square plate. And now what I'm going to do is I'm going to screw this plate to the bottom. When I lower it down into the bottom, it's going to stop gravel from getting sucked up from that vortex. And this thing will create a lot of suction. So by doing this, that's going to allow only water to come in over here on these sides. So it's going to protect it. So I have 2 of these pumps, and then I'm going to glue up my plumbing, and I should be ready to go. All right, metal plates mounted on the bottoms, bolted straight to it. I could drop them inside. I'm going to take my PVC pipes. I'm going to glue those on, have them stick out above for right now. Then I'm just going to connect on my flexible PVC and take it over to the storm sewer. Riser pipes are on, I should say. Now I'm going to drop them down inside the vault, connect up a rubber coupling on top, and then I'll connect up our main flexible 3-inch PVC, which is going to run all the way over to the storm sewer. Everything is connected. Cut the riser pipes down a little bit just to make that little sweep a little bit easier. So we have our 2 12-pan pumps, one located in each pit. You can see some of the turbulence down there in the bottom. I'm eventually going to put some fabric over that, and then we'll do soil, and that'll keep soil from migrating through it. So I set up my transit. I checked the water level here, and I checked the water level inside of our pit. The water level inside of here was 20 inches below that. So what appears to be happening is we're getting plugged up somewhere down over in here, so we're getting sediment and stuff like that. So I got my waders on, and I cleaned all this stuff out. You can see kind of now some standing mud over here in these shallow areas. Basically dug a deep trench, cleared all that stuff out to allow more water to get in, and now it looks like this is sucking back again. So I'm guessing we have too much restriction of the water as it's flowing through all of that gravel. That bentonite is definitely could clog up that gravel layer. We've had record-setting September and October here in Chicago, flood stages for all the rivers, so the groundwater level's high. The other thing is there's a large wetland over here that's at a higher elevation. You're just getting this hydraulic push of water. So hopefully we're going to figure this stuff out and get this liner in this year. Got my fingers crossed. See what we can make happen. All right, till tomorrow.